Hello everyone! Again, this is Teacher Abby, and for today's video, we're going to talk about long division of polynomials. And for today's lesson, we need to learn the following objective. Perform division of polynomials using long division. And before we proceed with our discussion, let us have a drill. This drill is called divide and write. Divide the following without using the calculator. Number 1, 29 divided by 5, 2, 34 divided by 7, 3, 145 divided by 11, 4, 122 divided by 7, and 5, 219 divided by 15. For number 1, the answer would be 5 remainder 4. Number 2, 4 remainder 6. Number 3, 13 remainder 2. Number 4, 17 remainder 3. And number 5, 14 remainder 9. In the division of polynomials, this is the division algorithm. If p of x and d of x are polynomials, and d of x is not equal to 0, then there exist unique polynomials q of x and r of x. Remember that p of x is our dividend, d of x is our divisor, q of x is our quotient, r of x is our remainder. Remember also that p of x divided by d of x is equal to the q of x plus r of x over d of x. In other words, if you're going to divide the dividend by the divisor, it will be equal to the quotient plus its remainder over by its divisor rather. Also, p of x is equal to q of x times d of x plus r of x, wherein the dividend is equal to the quotient multiplied by the divisor plus the remainder, where r of x is either 0 or of degree less than that of d of x. And in order for us to perform the long division of polynomials, here are the steps required for dividing a polynomial containing more than one term. Step 1. Make sure the polynomial is written in descending order, or in other words, it must be in standard form. If any terms are missing, use a 0 to fill in the missing term. Step 2. Divide the term with the highest power inside the division symbol by the term with the highest power outside the division symbol. Step 3. Multiply the answer obtained in the previous step by the polynomial in front of the division symbol. Step 4. Subtract and bring down the next term. Step 5. Repeat steps 2, 3, and 4 until there are no more terms to bring down. Lastly, step 6, write the final answer. The term remaining after the last subtract step is the remainder and must be written as a fraction in the final answer. And since we already know the steps on the performing long division of polynomials, let us now have an example. For number 1, y squared plus 8 divided by y plus 2. Remember, if any powers of the terms are missing, you should write them in with zeros in front to keep all of your columns straight. In other words, let us check first if the exponents are complete. So from raised to 2, we should have an exponent of raised to 1 followed by raised to 0. Since we do not have an exponent that is raised to 1, we're going to supply or insert the missing term, which will be 0y. So that the dividend would be y squared plus 0y plus 8. Since it is already standard and we have supplied the missing term, we can now perform the division. In dividing polynomials, always remember that the first term of the dividend should be divided by the first term of the divisor. That would be y squared divided by 1, which is equal to y. Then, after dividing, you should multiply the answer by the divisor. So, y times y, that would be y squared. And y times 2, that will be 2y. So, the answer would be y squared plus 2y. From there, let us now subtract, which changes the sign of each term in the polynomial. Let us now change the sign. From positive, this will be negative. From positive, this will be also negative. Okay? Then, let us perform y squared minus y squared, that will be 0. 0y plus, minus 2y, that will be negative 2y. Then, we're going to bring down the next term, which is plus 8. So, that will be negative 2y plus 8. And we're going to repeat the steps from division, multiplication, and subtraction. Again, if we're going to divide the first term from the dividend by the first term from the divisor, that will be negative 2y divided by y. And the answer would be negative 2. Then again, let us multiply negative 2 times y. That will be negative 2y. Then negative 2 times positive 2, that would be negative 4. And now, let us perform the subtraction. Let us change the sign. That would be positive, positive. Then negative 2y plus 2y, that would be 0. 8 plus 4, that would be equal to 12. Since we do not have any missing terms to put down, the 12 will be the remainder. And our final answer would be y minus 2 plus 12, which coming from the remainder all over by the divisor. Always remember that the remainder added should be over always by the divisor. For our second example, let us divide x squared minus 5x plus 6 by x minus 2. Again, let us check if the dividend is in standard form and if there's no missing term. So, the exponent should be 2, 1, 0. So, based on inspection, we can say that the dividend is in standard form and it has no missing terms. So, we can simply proceed on the division of the polynomial. So, from dividing this one, we should divide first the first term from the dividend by the first term of the divisor, which would be x squared divided by x. That will be equal to x. Then x will be multiplied to the divisor. So, x times x should be x squared. Then x times negative 2, that will be negative 2x. Then, now we're going to perform subtraction. Again, let me change the sign. So, since this is positive x squared, that will be negative x squared. And since this is negative 2x, will be positive 2x. And x squared minus x squared, that will be 0. Negative 5x plus 2x would be negative 3x. And now, we're going to bring down the next term, which is plus 6. Then, again, let us perform the division, followed by multiplication and the subtraction. So, first term by first term, negative 3x divided by x, that would be equal to negative 3. Then, multiply again to the divisor. Negative 3 times x, that will be negative 3x. negative 3 times negative 2, that will be positive 6. Then we're going to subtract. As we subtract, we're going to change the sign. So since this is negative 3x, that would be positive 3x. And since this is positive 6, this will be negative 6. Negative 3x plus 3x, that is 0. 6 minus 6, that is 0. So the final answer here would be x minus 3 with no remainder, since the last number that we able to come up is equal to 0. So the answer would be simply x minus 3. Okay? And now for our last example, we have divide 4x plus 2x raised to 3 minus 1 by 2x minus 2. So if you're going to notice, in this example, the dividend is not in standard form. At the same time, it has a missing term. So now, let us try to rewrite this one into standard form. So if you're going to write this one, we'll come up to the first decimal, or the highest decimal, that will be 2x raised to 3, followed by exponent of 2. Since there is no exponent of 2 from the given, we're going to supply it by 0 as the missing term, plus 4x minus 1. So that will be 3, 2, 1, 0. So that is in standard form. At the same time, it is already complete in terms. Now from there, let us now perform the division. That will be the first term by the first term of the dividend and divisor. That would be 2x raised to 3 divided by 2x, which will be equal to x squared. Okay? Now, x squared will be multiplied by 2x and negative 2. So, x squared times 2x, that will be 2x raised to 3. Then, x squared times negative 2, that will be negative 2x squared. And now, we're going to perform the subtraction. Since this is positive, this will be negative. And since this is negative, this will be positive. Then, performing them, that will be 2x raised to 3 minus 2x raised to 3, which is equal to 0. Then, 0x squared plus 2x squared, that will be equal to 2x squared. Then, bring down the missing term, the next term, which is 4x. So, that would be plus 4x. Then, the first term by the first term, so 2x squared divided by 2x, that will be equal to x. Then, x times 2x, that will be 2x squared. Then, negative 2 times x, that will be negative 2x. Then, we're going to perform again the subtraction, but before that, let us change the sign. So, since positive, this is negative, this is negative, this will be positive. Then, let us solve. 2x squared minus 2x squared, that will be 0. 4x plus 2x, that will be 6x. Then, again, since there's still a term above, we're going to put it down. Then, that will be 6x minus 1. Then, we're going to divide the first term by the first term. 6x divided by 2x, that would be 3. Then, multiply 3 times 2x, that will be 6x. Then, 3 times negative 2, that will be negative 6. So, let us change the signs. This will be negative, this will be positive. So, 6x minus 6x, that will be 0. Negative 1 plus 6, that will be equal to 5. And this will be our remainder. So, from there, we can already write our final answer, which is x squared plus x plus 3 plus, by the remainder 5, all over by the divisor, 2x minus 2. Since we're already done with our examples, now we're going to have your activity. In this activity, you're going to find for the quotient of the following expressions using long division. For number 1, 5x squared minus 35x plus 60 divided by x minus 3. Number 2, x raised to 3 minus 2x squared minus x minus 2 divided by x plus 2. Number 3, 18x raised to 3 plus 9x squared minus 5x minus 2 divided by 3x plus 1. Number 4, x raised to 3 plus 5x squared minus x minus 5 divided by x squared minus 1. So I hope you can answer this one since we are already done with our discussion. And that's all for today. I hope you have learned something. If you have questions, you can message me via Facebook Messenger, Abby Mendoza. Thank you for watching. Goodbye.